This video is probability basic concepts. What is probability? Probability is a way of describing how certain we are of the result of a particular experiment or activity. And the probability of something occurring is the proportion of times that it would occur if we repeated the experiment over and over. So if we were to flip a fair coin and toss it over and over and over again, it should come up 1/2 of the time. So the proportion of times that it would come up heads would be 0.5 or 1/2, and that would be the probability of flipping a coin and having a heads come up, having that occur. So here's some vocabulary. An outcome is one possible result of an experiment. So if we think about the flipping coin example, there are two possible outcomes. One outcome is flipping a coin and it landed on heads, and a second outcome would be flipping a coin and it landing on tails. Then we have what's called a sample space. This is just a space where you list all the possible outcomes. And you can express it in several ways. You can just list it and set notation, meaning you list it and you put little braces around it. So if you look at this example, if the experiment is rolling a 6-sided die, then here's the sample space. You could roll a 1, you could roll a 2, or a 3, or a 4, or a 5, or a 6. There's 6 different outcomes. You can list them as we did here and put them in braces, separated by commas, and that would be one way to express a sample space. Another way would be to create a tree diagram, and I'll be showing you that in a moment, how we could do a tree diagram. There are other ways. You can make tables, but any way that helps you organize all of the outcomes. Here's an example of flipping 2 coins and using a tree diagram to list all the outcomes. So first you can flip the first coin and it can either be heads or it can be tails. So you make branches. That's what's called a tree diagram. A branch for each outcome for the first flip. Now if it were heads, the second flip could be a heads or a tails. So you see you connect a new branch to the first outcome, to the first flip. So for the second flip you do a new set of branches. So if the first one is heads, then the second one could be a heads or it could be a tails. Or if the first one's tails, the second would be a heads or a tails. And you would get 4 outcomes: heads and heads, heads and tails, tails and heads, or tails and tails. 4 outcomes total. An event is one or more outcomes. So if you roll a 6-sided die, the event could be rolling 4. That's just one outcome, but that would be the event we're interested in. Or another event could be rolling an odd number. If we rolled an odd number, that would be the combination of a couple of events, 3 to be exact. Could be rolling an odd is the same as rolling a 1, 2, an odd 1, a 3, or a 5. Or you could say an event is rolling a number greater than 2. A number greater than 2 would be rolling a 3, a 4, a 5, or a 6. So it could just be one outcome, or it could be a combination of outcomes that would define an event. The way you could write part A, rolling a 4, to find the probability, you could write it P parentheses A. That stands for the probability of event A. Another way you could do it is write P and in parentheses write rolling a 4, probability of rolling a 4, or you could write P parentheses 4. The notation basically is if you want to write probability of an event, you would write P and in the parentheses you would specify the event. So you could see it was specified 3 different ways. Here it was specified with A and it was defined up here. Here it was actually explained that the event was written out in words, rolling A4, or they shortened it here and just wrote 4. All 3 of those meant the same thing. So let's look at an example. 2 siblings. Consider randomly selecting a family with 2 children where the order in which different gender siblings were born is significant. That is, a family with a younger girl and an older boy is different from a family with an older girl and a younger boy. So what would a sample space look like? Ignore this P. I believe that was a typo. So I'm going to make a tree diagram to list all the possible outcomes of a family with 2 children. So the first child could be a boy or a girl. So you list those 2 outcomes. Then you would go back here to, okay, well, what if the first outcome was a boy? The first child was a boy. What could the second child be? The second child could be a boy or a girl, and we branch off of that. Or the first one might not be a boy. The first one could be a girl, and if it's a girl, the second one could be a boy or a girl. And so then we end up with 8 outcomes. You could have a boy and a boy and a girl and a boy, or a girl and a girl. So 4 different outcomes for 2 siblings for a family. And there's the sample space. All right. What would the sample space look like if we considered a family with 3 children? Remember, the order of children born is significant. There's going to be 8 possibilities. So pause the video and try to draw out the sample space and then list the outcomes, the 8 outcomes for 3 siblings. So go ahead and pause. Okay, so hopefully you paused it, you listed your outcomes. So just check off all the outcomes that I have. Make sure you have the same ones because yours may be in a slightly different order depending on how you did your sample space. Okay, so I did this one with the branches going down instead of off to the side just to show you a different way that you could do a tree diagram. So the first one could be a boy or a girl. If the first were a boy, the second could be a boy or a girl. If the first were a girl, the second could be a boy or a girl. But remember, they're having 3 children. So if the first were a boy and the second were a boy, the third could be a boy or a girl. If the first were a boy and the second were a girl, the third could be a boy or a girl. If the first were a girl and the second were a boy, the third could be a boy or a girl. And if the first were a girl and the second were a girl, the third could be a girl, boy, or a girl. So you have boy, 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 girl. I have that one right here. Boy, girl, boy, which is right there. Boy, girl, girl, which is right here. Girl, boy, boy would be right there. Girl, boy, girl, right there. Girl, girl, boy, right there. Girl, 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 right there. So even mine was not in the order that I would normally write it in. But as long as you have those 8, you have listed the entire sample space. Okay, suppose we toss a fair coin and then roll a 6-sided die once. Describe the sample space. So you can do this as a tree diagram as well. Let's denote T for tails and H for heads. So here's the sample space. I should have given you an opportunity to pause and try it, but here you go. You could toss the coin and get heads, or you could get tails. Then you would roll the die. If you roll the die, after you flipped it and got heads, you could roll a 1, a 2, a 3, a 4, or 5, or a 6. If you flip tails first, then your die could be a 1, 2, 3, 4, 5, or a 6. So there's 12 outcomes here. There's a heads and a 1, a heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6. Same thing with tails, tails 1 through 6, total of 12 outcomes. Probability. So probability has a couple of basic rules, and they are as follows. P of A, remember that's the probability of an event. And notice you have it written as an inequality here. It says 0 is less than or equal to P of A, which is less than or equal to a 1. What that means is the probability of an event has to be between 0 and 1 for any event A. For any event, the probability is always between 0 and 1. That's what that means. It can be 0, it can be 1, or it can be in between. It can't be anything outside of that. If you did have a probability equal to 0. It just means that the event will not occur. It's not possible. Probability of an event equaling 1 means that the event is certain to occur. It definitely will. And then the sum of the probabilities of all the outcomes of an event is 1. So, going back, probability has to be between 0 and 1. A probability of 0 means the event won't occur. A probability of 1 means that it definitely will occur. And if we listed all the outcomes, all of those probabilities would add up to be 1. So let's talk about theoretical probability. Theoretical probability is the probability in a perfect world. If the world were perfect, how likely is this event to happen? So probability of A for theoretical probability is the number of ways A can occur. So you have to figure out how many ways can you toss a coin and it land on heads, or how many ways can you roll an odd number on die, and that would be the number that goes on top, and on the bottom is the total possible outcomes in all, and then you just divide the two. We normally write this as a decimal rounded to the 4th decimal place, although technically you could leave it as a reduced fraction, or you could change it to a percent, but mostly we leave it as a decimal, as a proportion. If you think about this, this is really similar to how we find relative frequency. So assume you're rolling a fair-sided die, a fair 6-sided die. What is the probability of rolling an odd number? So you have to figure out the number of ways that an odd can occur. So an odd can occur by rolling a 1, a 3, or a 5. So that's 3 ways. And then you divide that by the total number of possible outcomes. So how many outcomes are there if you roll the die? There are 6 sides, so 6 outcomes. So that would be 3 out of 6, which is 1/2. And you could write that as 0.5. And there would be no need to round there because 0.5 only goes out 1 decimal place. Okay. All right, consider the earlier example of the family with 3 children. Remember, the sample space looks like this. Okay, so I have them listed up here. I'm not going to read them out again. That's a total of 8 outcomes. Okay, so find the following probabilities. Why don't you pause the video and see if you can find the probability of each of the following A through E. Okay, hopefully you had the opportunity to pause the video and try these. So the probability of 3 girls. So we'll go back up here and look. There's only one way to get 3 girls. There's only one possibility. So that's one possibility out of 8. And I believe that's 0.125. Let's skip to C. What's the probability of exactly 1 girl? So there's exactly 1 girl right here, and there's exactly 1 girl right here, and there is exactly 1 girl right here, and everything else has 2 or 3 girls or no girls. So that would be 3 out of 8, which is 0.375. What's the probability that the youngest is a boy? So let's go through. The youngest being a boy is here, 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 here. That's 4 out of 8, which is 1/2 or 0.5. What's the probability that the oldest and the youngest is the same? So let's see, boy and a boy. Looks like that one is 4 out of 8, which is 0.5 again. And going back to B, the probability of 2 or more, which is at least 2, which means 2 or more, it looks like there are 4 of those, so that would be 0.5 as well.